linear approximation and differentiation. This is the next topic, 4.2. So let's start with describing the linear approximation to a function at a point. Let us say that I have to find the linear approximation of under root x. So question is, find the linear approximation of f of x equals to under root x at x equals to 9 and use the approximation to estimate under root 9.1. Okay, so this is the function at x equals to 9 and we have to approximate the value at under root 9.1. Okay. Since we're looking at linear approximation at x equals to 9, so the formula of linear approximation is L of x equals to function which is given f of x. So function is what? X equals to 9. So f of 9 plus function derivative of 9 into x minus 9. So this is my constant formula when finding the linear approximation. Again, I will write the general formula here. That is, if the number is this one, L of x, I have to find. So it will be function, let us say x equals to a. So it will be a plus f derivative of a with a minus 9. Sorry, x minus this. Function of derivative of a with x minus a. Okay, so a, let's say a is a number. Up a is point p, this equals to x equals to 9. So let x equals to 9. So मेरे यहाँ पे a की जगह replace हो जाएगा 9. So it will be 9 here. Also there's a 9 here and there's a 9. So my formula will be function of 9 plus function derivative of 9 into x minus 9. Now, first thing I have to find the value of this one, function at 9, then function derivative of 9, and then x minus 9. Okay, so there are three unknowns. So for this, f of x equals to, as the function equals to under root x, so it will be f of x equals to under root x. This means that function at the value x, that is 9, equals to under root 9 equals to under root 3 square. So this square and this square will cancel out. So function at 3 equals to 3. Function at 9 equals to 3. So this is the first value. Now the next value is f derivative of x. So as f of x equals to under root x, I have to take the derivative of this value. So it will be as it is equals to x 1 upon 2. Okay, so it will be 1 upon 2 x 1 upon 2 minus 1. So it will be 1 upon 2 x minus 1 upon 2. It will be 1 upon 2 under root x, because in denominator the value is negative. So when it comes to denominator, so it will take a sign change. So my value will be positive. So it will be 1 upon 2 under root x. Now I have to find the f derivative of 9. So putting x equals to 9, so 1 upon 2, it will be 9. So it will be 9 is 3 square, so it will be 2 multiplied by 3. So the answer is 1 upon 6. Okay, so this is the value of what? F of x, and this is f derivative of x, that is f of 9. Okay, now my L of x equals to f of value 9 plus f derivative of 9 with x minus 9. So this will be f of 9 will be 3. So it will replace as 3. This value is 1 upon 6 and this is x minus 9. Okay. Now we have to estimate under root 9.1. Okay, so the value will be written as under root 9.1 equals to function of 9.1, and I have to approximate it with linear approximation, so it will be L 9.1. Okay, so I have to, this value equals to this value 3 plus 1 upon 6. Now the I have to estimate the value 9.1. So I have to replace my x with 9.1. So I have to replace here, that is 9.1 minus 9. Again, the value which must be approximated should be replaced by the value x. So my x has 9.1 in this case. So this will be approximately equals to 3.0167. Okay, so this is the value that we have found by using linear approximation method. This graph shows basically point, and f(x), the value we have to put x equals to 1, 2, 3 and simultaneously make this, and this is the view line basically shows the linear approximation line, which is a straight line due to power equals to 1. So it will make a tangent at 0.93. So this will make that this is approximated the local linear approximation to fx equals to root x at x equals to 9 proves an approximation to function for x near to 9. Okay. Okay, analysis. This is the part of this numerical third part. Okay, analysis using a calculator, the value under root 9.1 to 4 decimal number, it will be 3.0166. Okay, so first by using calculator, under root 9.1 equals to 3.0166. The value given by linear approximation is 3.0167. The value we find here. Okay, this value. So it's very close to the value obtained with calculator. So it appears that using linear approximation, this linear approximation is a good way to estimate under root x, at least for x near to 9. Okay, so at least at some time it may seem odd to use a linear approximation when we can just push a few buttons on calculator to evaluate under root 9.1. However, how does the calculator evaluate under root 9.1? The calculator uses an approximation. In fact, calculator and computer uses approximation all the times. Okay, so evaluate the mathematical expression. So they just use higher degree approximation. So this is the way that calculators and my computers perform calculations by using higher degree approximation. Now the next question is linear approximation of sine x. So sine x, we have to find linear approximation of sine x at x equals to root x equals to pi upon 3 and approximate sine 62. Okay, so first this pi upon 30, as pi is 180 divided by 3 is 60 degree. So using linear approximation, x equals to pi upon 3 seems to be, as we know that L of x will be function value x equals to what, pi upon 3, so it will be pi upon 3 plus function derivative pi upon 3 into x minus value which is given, that is pi upon 3. So this is the linear approximation. I will write my function like this one. Okay, So I have to find the f of this one. This one is basically what this is the value of fx. So fx equals to f sine theta. Again, I have to write here. It will be Lx. It is, let's say, f of x. F of, in this case, it is f of 60 degree. F derivative of 60 degree into x minus 60 degree. Okay. So for function at 60 degree, so my primary function is f of x equals to sine of x, and just putting the value of x equals to 60 degree, so I find that sine 60 will be equals to this one. Okay. Now what f derivative of x, so I have to take the derivative of sine, so it will be in the next slide. It will be that f of x equals to this one. So sine 60 is under root 3 upon. Now derivative, f derivative of x is sine x is cos x. So putting cos 60 degrees, so value is 1 upon 2. So my approximate value L of x with function value under root 3 upon 2 plus 1 upon 2 x minus value of this. Now I have to approximate sine 62. So sine 62 will be sine 62 degree. Okay, I have to convert this degree into radian. So to convert degree into radian, I have to multiply with pi upon 180 with 62. So it will be 62 pi divided by 180 radian. Okay, 62 degree equals to 62 upon 62 pi divided by 180 radian. Now I have to approximate it. So sine 62 will be function of what? 62 pi upon this one, 180, or it is linear approximation of 62 upon this one. So this will be first value, that is under root 3 upon 2 plus 1 upon 2. Now what is the value of x? X value is 62 pi divided by 180 minus this one. Okay, so after the calculation, so I have to first I have to take the LCM of this and solve this bracket. Then after the value is 2 pi divided by 180. So the answer will be under root 3 upon 2 plus pi upon 180, which is equals to 0.88348. Okay, so these are the values. So we find by using linear approximation. So this is the point. This is the point basically at pi upon 3 and under root 3 upon 2 of the function value. Okay, function value. Okay. Next is approximate roots and powers. Let us say one function is 1 plus x power n whole power n at x equals to 0, and I have to approximate at 1.01 cube. So how to do it? The linear approximation at x equals to 0 is given by this one, that linear approximation L of x equals to function of x, that is 0, plus function of derivative of 0 into x minus 0. Okay, so this will be function of x is 1 plus x power n. So when I put here x equals to 0, so it will be 1. Derivative, derivative. So derivative will be this value n into first I have to take the derivative, that 1 plus, this is my function value. So it will be n into 1 plus x and minus 2. Now I have to put x equals to 0, so it will be 1 plus, this is x 0 into n minus 1. So 1 plus 0 will be 1, and the power of 1 equals always equals to 1, so the answer will be n. Okay, so this is the derivative value. So I have to put function f of 0 equals to 1, then derivative value of 0 equals to n, and x minus 0, so it will be 1 plus nx. Now the next thing is I have to approximate 1.01 whole cube. Okay, so whole cube means that the value of n equals to 2. Here, the value of n equals to, because my function equals to this one, so my value n equals to 3. So it will be written as 1. The function is this one, and now x equals to 1 plus nx. That is linear approximation. Now finding 1.0, so it will be 1, a linear of 1.01 will be 1 plus, now the value of n is what? N is basically 3. Okay, so basically I have to approximate 1.01 whole cube, so it will be n equals to 3 with the value of x. Okay, with the value of x. So what is the value of x? So the value of x we find is 0.01. 0.01. Okay, so basically we can approximate 1.01 cube by evaluating. One thing to remember, that when I have to make 1.01 whole cube, so the evaluation will be 1 minus, sorry, 1.01 minus 1. So the answer is 0.01. Okay, so I have to linear approximate this value 0.01. Okay, so 0.01. Okay, and the value of n is 3. Okay, so n value is 3. So n equals to 3. Just putting that L of x equals to 1 plus nx. So it will be 1 plus, what the value of n is 3, and x is 0.01. So it will be 1.03 is the answer. Next is computing differentials. So how to compute differential for each of the following? Find dy and evaluate x equals to 3 and bx equals to 0.1. Now first function is y equals to x squared plus 2x and y equals to cos x. So I have to take that function value is x squared plus 2x. So f of x will be equals to x, and derivative will be 2x plus 2. This derivative means that dy upon dx, 2x plus 2. So I have to find the dy. So dy will be 2x plus 2 and with t of x. Okay, so now I have to put the value of x. Now 2x so I will put this value x equals to this one. So x will be my this value plus 2 and dy value is given, that is 0.1. Okay, so this is the way to find the value of So this is the way we find the values of by derivative functions. Now the next thing is there's a value that is d of x equals to 0 0.2, but I put x equals to this value and my answer will be answer will be 6 by putting x equals to 3. Now x equals to 3 and with d of x equals to 1.1. So it means that 0.1, there is first addition of 0.1 and x equals to 3. So simply I have to multiply this parameter with this. So it will be 3 multiplied by 0.1, so answer will be 0.3. Okay, so I have to sum this value with 2, so it will be 2.3 plus 2 with d of x equals to 0.1. 0.8.